I'm going to show you how to solve conservation of energy problems. And I think it's also important that you not only look at I'm going to do one example in this video, but I think you should look at the other three examples as well, because it's the sort of thing you have to learn by just seeing someone solve problems over and over and then trying it yourself. This is the notion, is that if we look at some system, the total energy before is going to equal the total energy after. And mathematically, this is what we mean. Sometimes kids like to think of the energy comes from someplace and goes to someplace. Or the more financially minded might think of, money, some sort of asset becoming an expenditure or something like that. Ultimately, though, here's this big scary thing, but convince yourself that this is just the formula for work. That's potential energy, right? That's kinetic energy, right? Okay, and if we add up all of those things all are energy, and if we add those all up before, it's going to equal the sum of all of those after. Now, it's my fondest hope to actually make a problem that has all of these three becoming all of those three, but that's probably just not going to happen, which is sort of sad if you think about it, right? But anyway, this is the notion: is that we might have a hill, and we've got a car or something like this, or whatever. It might be moving on the top of the hill, so it has kinetic energy, right? It's definitely on top of a hill, so it's got some potential energy. And then, we could exert a force over some distance in that direction, right? Some force, right? And in that case, that force, if it speeds you up, right? Why did I write it that way? Okay, if it speeds you up, specifically if the force is in the direction, that's the force, and the distance is the same direction, right? Then it definitely is an asset, okay? Okay, and then sometimes if there's like a puddle or friction or something like that, if it's a force that slows you, then it goes on the right side. And that's really the only one that you really have to think about is force and distance. You either are on top of a hill, right? And you either are moving or you're not, right? And then in the end picture, right, and like in this picture here, right, we get down to the bottom of the hill, maybe we don't have any potential energy, but we have all kinetic energy, and maybe there's also a force that slows us or something like that, right? And I can talk all I want about it, but really the thing to do is to solve one for you. So let's solve this. So here's this car. Here's what it would look like if it was just a word problem. But I've drawn a picture, and I highly recommend drawing pictures to solve these things. But if it was a word problem, it would look like this, and here's the picture of it, right? And what's the velocity at the bottom? Now, presumably the velocity at the bottom will be more than 4.5, just because it's gained, this potential energy has turned into all kinetic, right? So if you look at it, here's before, here's after, right? So the left side, this will be the left side of the equation, that'll be the right side of our equation. Put an equal sign there, right? Well, gee, it's on the top of a hill, so I think it's got mgh, don't you think? Right? It's moving, right? So it's got 1/2 mv squared, right? And then that's it. There's no mention of any force, right? Anywhere. So there's no force times distance on either side, right? And then at the bottom of the hill, well, I don't think there's any mgh because the height is 0, right? But it is moving, so I think it's all kinetic at the bottom of the hill. So sometimes you can just sort of, by elimination, right? This is the only thing it could have. It's just moving. It's not at any height. But here it has a height, and it is moving, right? So now I can just put the numbers in, right? 250 times 9.8 times 1.75 plus 1/2 250 times 4.5 squared equals 1/2. And then this is what we don't know, is that velocity. And then mathematically what you want to do is just type these numbers in, right? So 250 times 9.8 times 1.75 is 4287. And then this guy, 0.5 times 250 times 4.5 squared, 2531. and then half of 250 is 125. Okay, and then I can add these guys together, right? In fact, usually I just type this whole thing in and just get this side all added together. Go this plus that, but anyway, here we go. So 4287.5. Okay, now the next thing to do is to divide both sides by 125. And you get 54.55 is v squared, right? And then I'm going to square root both sides. I get 7, v is 7.3857, right? And then since we have 2 digits here and really just 2 digits there, we'd have to write this about 7.4 meters per second. Okay, but beyond this point, it's all just math. Hopefully, we can do the math, right? Highly recommend that you look at the next 3 examples.